Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM on financial mathematics. You are given the following information about an investment account, and you are given the account value before deposit or withdrawal on January 1st, 1992, March 1st, 1992, April 1st, 1992, a certain time in 1992 denoted by T, and then January 1st, 1993, and the account value is respectively 100, 108, 102, 118, and 130. There is a deposit of 20 on April 1st, 1992, and deposit of X at the time T in 1992, and there is a withdrawal on March 1st, 1992 of 12. The time-weighted yield rate is 13.61, and the dollar-weighted yield rate is 12.04%. Calculate T. And here's the solution. Based on the information on the time-weighted rate of return, we have 1 plus the time-weighted rate of return over the whole year is equal to a product of accumulation factors over all periods without any contributions or withdrawals. So we split the whole year into the periods in which we know the initial balance and the final balance, and those two are calculated for the initial balance after any transaction just made, and the final balance before any transaction just made. There are 4 separate periods like that in the year. In the first period, 100 goes to 108. In the second period, 96 goes to 102. In the third period, 122 goes to 118. So you can see that that's the first time that the value of the account declines because of negative rate of return in that period. And then in the fourth period, 118 plus X goes to 130. So we calculate these accumulation factors over those 4 periods, and we multiply them out, and the product has to be equal to the accumulation factor over the whole year. And this is an equation in which only X is unknown. We calculate X, and it's 9. Then let us write Y for the fraction of a year that the deposit of X equal to 9 was in the account. And then we write out the formula for the dollar-weighted rate of return, which you should remember is calculated using the assumption of simple interest. And that dollar-weighted rate of return, which is known to be 12.04%, is equal to the net increase in the value of the account. That's the numerator calculation. So 130, the final balance, plus 12, which was taken out, minus 100 initial balance, and minus 20 and minus 9, these are the amounts that were put into the account. So the result is the net increase over the whole year. And then at the bottom you have all initial balance and all deposits multiplied by the fraction of the year that were in the account with a positive coefficient, and withdrawal multiplied by the fraction of the year that it was not in the account, that was taken out for, with a negative coefficient. So 100 was there initially, and we multiplied by 1 for the whole year that was in the account, minus 12, the withdrawal, times 10 over 12, which is the fraction of the year that it was out of the account, plus 20 times 9 over 12. 20 was put in such a way that it was in the account for 9 out of 12 months, plus 9 times y, which is that fraction of the year that the deposit of 9 was in the account. And this is again an equation in which there's only one unknown, y. And once we do the calculation, we find that y was 1/3. So y was put, so x equal to 9 was put in the account in such a way that it was in the account for 1/3 of the year. Well, that means that it was put in at the beginning of September, just as September was starting, and it was in the account for September, October, November, and December, 4 months out of 12, which is 1/3 of the year. So T is equal to September 1st, which is answer C. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries. The solution is mine. Good luck in your studies, and good luck on the test.